Look at this, everybody. We got once again, and I probably hear. I was like, I feel like I heard a question in my deep in my mind. It was like, how do you know that those are metals, Dr. J? Okay, so let's talk about that. Let's talk about that. So the metals, here are our metals, right? We got alkali metals. Y'all remember that those groups? We got alkaline earth metals. All right, so these are metals. This whole middle row, this whole middle section, we call these transition metals. Okay, so basically all of these are metals. All right, now let's focus on the non-metals. So basically, where you see this little dark line here, there's a reason for this. This is kind of letting me know that some of these are metalloids. Don't worry about metalloids right now. We just focus on metals and non-metals. So to the left of this dark line, we got metals. Besides hydrogen. Hydrogen is not a metal, it's a non-metal. Everything towards the right, right, is going to be a non-metal. Okay, so everything towards the right of this dark line here, right, non-metals. So carbon, non-metals. Oxygen, non-metal. Neon, non-metal. Okay, so we can see we actually have more metals than non-metals. Okay, and this is how we know, right, when we have a metal and a non-metal. In the middle here, we have transition metals. Transition metals can have multiple oxidation states. Okay, so this is what we see here with all of these elements here in the middle, right? Not the main groups, all right? Not these main groups over here, just the middle section. These are transition metals. They can have multiple oxidation states. So they can have multiple charges, basically, okay? Now, because of this, right, we had to do our naming, our ionic compounds a little differently, okay? So, with the second type, all right, we had to use Roman numerals in order, right, to indicate what our charge of that metal is, okay? So, it's going to tell me the charge of the metal. Let's look at an example here, okay? So, we got CrBr3. CrBr3, metal, non-metal. I know that this is an ionic compound now. With it being CrBr3, chromium, right, is our metal, so that's going to stay the same here. Bromine is our non-metal. Okay, so we're going to change that to bromide, which we see here. But here's the thing that we want to pay attention to. And this is where I was talking about this. All right, this is going to be very critical for this part. All right, we have charge for our chromium of 3. Okay, so this is chromium 3 bromide. So it's telling me that my cations first, anions second, and now this 3 is telling me, all right, this is the charge with the chromium. Let's look at iron over here. So we have iron, and then we have oxygen. So iron is our cation. Oxygen will be turned to oxide. And this 3 here is letting me know that we have a charge for iron of 3. Okay, so this iron has a positive 3 charge. Okay, we're going to do multiple examples of these. So if you're wondering where exactly the charge comes from, stay tuned. Stay tuned. Now, the location of your anion, all right, is basically this is what's going to help us determine our charge. Okay, so this is what's going to help us determine our charge because we understand, right, what, like for instance, iron can have a +2 charge and a +3 charge. So we can have those multiple oxidation states, right, those multiple charges. Okay, so your anion, right, is the thing that's going to be telling you what that charge is. So the reason being, right, the anions are usually your main group elements, so they always are going to have the same charge. Group 7, if we remember halogens, right? So if we look at group 7, Group 7, when I say 7, this is going to be a -1 charge. Group 6 is a -2 charge. Let's go to group 6. -2 charge. So this entire family, -2 charge. Group 5, -3 charge. Okay? And we're going to explain, right, why there are these charges later on in the semester. Later on. Right now, y'all just need to know, right? Group 5, if you're in group 5, you're going to have a -3 charge. If you're in group 6, you're going to have a -2 charge. And if you're in group 7, you're going to have a -1 charge. Start memorizing, right, these charges. They will help you in the long term. Now that we know the anions, right, and their charges, we are able to assign our cations based on that charge. Okay? So for example, if we look at this one here, CuCl, right? Cu is copper, transition metal. So it's going to be first copper. Chlorine is our anion. So we're going to change that to chloride. IDE right here. All right? Now, this is where you have to pay attention to, because the charge is key here. Copper can have multiple charges. How do we know which one is it, right? So think about it. I mentioned before, this is key, right? The sum of charges of positive ion must equal the sum of your negative ion, because it's a neutral compound. This is a neutral compound, copper chloride. So my positive must equal my negative, right? As far as with the charges. So if I know with chlorine, this is a -1 charge, what does my copper have to be? +1, all right? So our copper must equal, right, that positive and negative. Chlorine is -1. So the only thing that's going to get me to a neutral compound is copper being a +1. Right? So since copper is a +1, I'm going to put a 1 here for my metal. Okay? So always remember, right? This number here goes with the metal. It's never going with the anion. It always goes with the metal.